Hi, this is Leetcode question, minimum cost to split an array, and this is the last question of weekly contest number 329. In this question you need to return the minimum possible cost of a split of nums. For example, for this array nums we can split it like this. So the first subarray, how many non-unique elements we have? One is not unique, so we have 1, 2, 3 ones, and we have 2 is not unique, we have 2 2s, so in total we have 5 non-unique numbers plus k equal to. For this subarray, second one, 3 is not unique and we have 2 3s, so the number of non-unique element on this subarray is 2 plus k 2, so we have 7 plus 4, the result is 11. Now if we do the partition in different way, let's take this as first subarray, and this is second subarray, and this is the third subarray. For this subarray we have 1 is not unique, we have 2 1s, and 2 is not unique, so we have 2 2s, and in total we have 4 non-unique numbers plus k 2. For this subarray, 1 is unique, so we skip it. 3 is unique, we skip it, so we have 0 non-unique elements plus k 2. For the last subarray, we have 3 is unique, so we skip it, 0, the number of non-unique element is 0 plus k is 2, so in total we have 6 plus 2 plus 2 which equal 10, and this is better solution than the previous one. Now if we do splitting like this, for this subarray we have 2 is unique, we skip it. We have 1 is not unique, we have 2 1s, this and this, so we have 2 non-unique elements plus k 2. For this subarray, 1 is unique, so we skip it. 2 is unique, we skip it. 3 is not, we have 2 3s plus k 2. So in total we have 4 plus 4 equal 8, and this is the minimum possible cost for this array, and we need to return 8. Now how can we solve this problem? First of all, we need to know for any subarrays how many non-unique elements. So if we have I and j, where j is less than I, for any I and j less than or equal, we need to know how many non-unique elements on this subarray. For example, if I equal 3, 0 1 2 3, this is I 3, and if we have j equal 1, this is j, we need to store in the table how many non-unique elements in this subarray from 1 to 3, and in this case we have 2 1s, so it will be 2, and we need to do that for every I and j, and we do this in this part of the code. Here we have 2D vector length that will store the number of non-unique elements for any sub array. We have this 1D count that we will use while iterating and calculating the, so its menu will store the number of occurrences of any element, and initially we set it to 0. We have this variable c. C will accumulate the number of non-unique elements. So in the external loop we are going from 0 to n. N is the number of elements, and for every I we will iterate from j equal I until 0. For example, if we have this I 0, 1, 2, 3, which equal I equal 3, index 3, so we will calculate the number of occurrences for j equal I 3 and j equal 2, j equal 1, then j equal 0, and we will do the 2 by taking advantage of the value we calculated for 3. So for j equal 3 it's this subarray, then for j equal 2 it's this subarray, and for j equal 1 it's this subarray, for j equal 0 it's subarray, and every one we will take we will use the previous value we calculate for the previous index to do the next index. And to do that we have this, as we said, the count. So initially the count is 0, and while iterating we will increase the count. So here count is 0 and we start from this index. Now 2 become, we have 1, 2, and here we need to check if this count is greater than 1. If in that case it means that it is not unique and we need to increase the value according to that. So if the value is 1, that means it's unique. If it's 2, then that means we have to set the variable to the value 2, and this is why here first we increase it by 1, then we check if it's 2, we add another one. So initially it's 0, then here it's 2, so 2 become 1, then when we come here it's 2, so we have 2 2's, and the number of occurrences here is 2. This is why we need to do 2 times. Now if we have another 2, so we have 3. C is already equal to 2, and we only need to do this C++, so the value will be 3. Now as we said, 2 equal 1, so we have 1, 2, and so for length of ij for this subarray 3, 3, we will store the value c, which is 0, because still it's less than 2. Now we go and calculate for the next iteration j equal here this subarray. Now we have 1, so we have only 1, and again this is unique. Then we go to this j to calculate this subarray, so we have 2 2's. Now c equal 2, and so we store in the length of I of j equal 2. That means length of I, which is 0 1 2 3, and j1 equal 2. This is the number of non-unique numbers, and so on. We do this for all the vector, for all i's and all j's. Then after that we will use dynamic programming to solve the cost or the minimum cost for every I and j. So here we have this 2D table that will store the minimum possible cost for every I and j. So we pass to it the length array, so that for any I and j we can retrieve easily the number of non-unique elements, and we have the table. We pass it to store the minimum possible cost for every I and j, and I is initially 0 and j is initially 0 also. This is the constant k, and so this is the size of the array nums. Now if we already calculate for I and j, and we know that by checking the value if it's not -1, because initially all the values are -1, and if it's not -1, it means that we already knows the minimal cost for I and j, so we just return the value. Now if I equal n minus 1, if we are I here, and let's say j is here, so there is no way to move I forward, because this is the last index in the array, and that means we need to return the solution for this subarray, which is k plus length of ij. Length of ij is the number of non-unique elements in this subarray. If I is not the last one, we have two choices here. For example, if I is 0 and j is 0, we can either take this as subarray and calculate the minimal cost for this subarray, and we do this in the first statement. So k plus the number of non-unique elements in this subarray, this is the cost for this subarray, plus the minimum for this for the remaining part. So we call fs and we pass it I plus 1 and I plus 1, and that because we will start from beginning here. We need to calculate for this substring, and we start from the first element. So after we done for this part and we need to calculate for this part, always I and j should start from the first element. And this is, for example, here when we call the first time, I and j are 0 and 0. Another example, if we have j equals 0 and I is here 2, and we decided to take this as a subarray, then we calculate for this, which is k plus length of 0 and 2. Then we need to solve for this, so I and j are 3. Now the other option is we don't take this as subarray, so we keep j and we just move this I here, so j stay here and I become here, and we need to solve for this, so dfs of length db, and we only increase I plus 1 and we keep j as is, and the result or the optimal solution will be the minimum between these two results, and we store it in the table. Okay, the time complexity for this solution is here we have 2 loops, so it's n square, and also we need n square for space complexity. This function also cost big of on n square, so the time complexity for this is big of n square.